For most of this video, we will discuss the relationships between arcs and angles. That's where if the vertex is at the center, the angle is equal to the arc. If the vertex is on the circle, the angle is half the arc, or you could say the arc is double the angle. If the angle is vertex in the circle, then the angle is equal to arc plus arc divided by 2. And finally, if the vertex is outside of the circle, then the angle is equal to the big arc minus the small arc divided by 2. But before we do that, we need to do a little circle vocabulary. So let's see. Take a look at line AD. Alright, line AD is this line right here, passing through A and D and going forever. That is a secant, because a secant is a line that cuts through the interior of a circle. So this is definitely a secant. Alright, now, let's erase that and start over. And let's compare that with segment AD. Alright, segment AD begins and ends at A and D. That is a radius, because it starts at the center of the circle and goes out to the edge of the circle. That's what a radius is. Alright, next we have arc CDB. Alright, arc C, and then to D, and then around to B. That is a major arc. Clearly that is more than half the circle, so that makes it a major arc. Major arc. Alright, next we have line ED. Alright, so here's line ED out here. That is a tangent. Alright, a tangent is a line that just skims the circle, touching only one point. So that is a tangent. And by the way, point D, where it touches, is the point of tangency. So, you know, point D is not one of the choices, though. So I guess we won't be using point of tangency. Anyways, it's good to know. In fact, I think off to the side here, I'll put point D for point of tangency, even though it's not one of the choices, just for educational purposes. That's what we're here to learn. What about segment CD? Okay, so here's segment CD right here. That is a chord. Alright, a chord is a segment that begins and ends on the circle. So that is a chord. Okay, wait, I meant to cross it out. Chord. Alright, what about angle CDB? Alright, angle CDB. Alright, this is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle. So this is an inscribed angle. Alright, so now I'm just going to run through the ones that did not show up yet and give an example of each just for the purposes of learning. So diameter. A diameter is a chord similar to CD is a chord. It begins and ends on a circle. But if you have a chord that goes through the center of the circle, that's a diameter. Okay, so for example, segment BD would be a diameter. Okay, a central angle is an angle whose vertex is at the center of the circle. So for example, angle CAD would be a central angle because vertex is at the center. So I could say angle CAD would be a central angle. And a minor arc is an arc that is less than half the circle. So for example, I could say arc BC would be one example. There are many, but arc BC would be a minor arc. And of course, a semicircle is half of a circle. So if I said arc BCD, that would be a semicircle. Alright, for problem number 2, we are dealing with central angles. Alright, all of these angles have the vertex at the center. And that means that the angle and the arc are going to be the same. So for example, I see this arc that's 68. That means that this angle is also going to be 68. I'm going to constantly be looking around for diameters. So for example, I like to draw my diameters in turquoise for some reason. Don't ask me why. So here's a diameter. That makes this down here a semicircle. So I should be able to subtract 68 from 180 to find this other part. Okay, so if I go 180 minus 68, that leaves 112. Okay, so that means that this is 112 degrees, and this angle is also 112 degrees. Okay, now let's use vertical angles. This 68 right here and this angle right here, these are vertical angles. Vertical angles are always equal. So if this is 68, that means that this arc right here is also going to be 68. Okay? Now, looking at this pair of angles over here, there's a couple ways you can look at it. One way to look at it is that this angle FAE is 112. That means that this angle BAD is 112, all right, because they are vertical angles. And then the key is going to be, see these markings? That means these two parts are equal. So if you take 112 and divide by 2, that's going to be 56. So that means each of these will be 56. Now if you weren't comfortable with the whole vertical angle thing, instead you might have thought of it this way. See this diameter? Again, what we have here is a semicircle up top. So if I were to subtract the 68 from 180, we already saw how that went down. All right, 180 minus 68, that's 112. So that's another way of seeing that this arc right here is going to be 112. And then again, you had to divide it into two equal parts. Now that we have all of the angles and arcs labeled, we should be able to answer any question they want to ask us. So let's see what they actually asked us for. So the measure of angle EAF. So EAF is this 112 degree angle. The measure of angle CAB. So CAB is one of these 56 degree angles. The measure of arc DBE. So DBE. Alright, DBE is this giant arc that goes all the way around like this. Alright, DBE. So that's everything except for 68. So probably the quickest thing to do would be to start with 360 and just subtract the missing 68. So 292 degrees is what we're looking at. Okay, and then that just leaves arc FED. Okay, FED, well, that's a semicircle. So of course that's 180. So 180 degrees. As we pick up here on number 3, we're moving on and dealing with this second arc angle relationship. So remember, if you have an angle that is on the circle, vertex on the circle, the angle is half the arc is double the angle. So you have to be aware that that's what we're looking at right here. This angle is an inscribed angle. The vertex is on the circle. So if I knew what this arc was, the angle would be half that. Now, this is a semicircle. I should probably start with that. Let's see. Okay, so here's a semicircle. There's the diameter. That makes this a semicircle. So if I subtract 108 from 180, then that's going to leave 72. So that means I've got 72 degrees right here. And then, like I said, I've got this inscribed angle, which has to be half of that. Okay, so if I take 72 divided by 2, that's going to be 36. All right, let's see what we've got. So the measure of arc BC is 72 degrees, and the measure of angle D is 36 degrees. Problem number 4 uses another rule that I haven't really mentioned yet. It's down here at the bottom of the screen. If you have a quadrilateral inscribed in a circle, the opposite angles are supplementary. That means that the opposite angles have to add up to 180. So you see the 74 that's right here. The opposite angle is angle E that's up here. These have to be supplementary. So of course, if I subtract 180 minus 74, you're going to get 106. So that means this angle right here is 106. Now, other information that we have. Let's do the semicircle thing. Here's a diameter. Alright, that means we have a semicircle up here. Okay, now we have ourselves this is an inscribed angle, right? Angle C, the 74 degrees, that's vertex on the circle. So the angle is half of this arc. The arc is double the angle. So if I take this 74 and I double it, that's 148. That tells me that this arc, all right, DEB, is 148. All right, so this arc is 148 degrees up there. All right, better pause and look at what we are actually being asked to find. I could find other stuff, but we're supposed to find the measure of angle E. That's 106 degrees. We've already found that. And we're supposed to find the measure of arc BD. Arc BD is the purple arc right here. That is 148 degrees. For number 5, we got to move on to some other formulas. So, when you have a vertex that's outside the circle, the relationship is the angle is equal to the big arc minus the small arc divided by 2. So that's the situation that we have right here. So I'm going to write that down. Now, what are these two arcs? I only see one arc right here. Well, I'm hoping you can see that the black arc and this red arc together make the entire circle. Alright, so we've basically divided the circle up into two arcs, black and red. So I should be able to easily find the measure of the red arc by subtracting from 360. So 360 minus 114 is 246. So this red angle is 246. So that is the big arc. So angle E, I think I'll just call that X for right now. But so that gives us X is equal to 246, all right, the big arc, minus the small arc, 114, divided by 2. Okay, so I should be able to just put this all in the calculator. So 246 minus 114 divided by 2. So that's 66. Okay, so that means that this angle right here is 66 degrees. So that's the measure of angle E, is 66 degrees. And how about arc BDC? BDC is the red arc, which was 246 degrees. Alright, number 6 is a little bit different. Alright, we're in this situation right here, when you have the vertex inside the circle, not at the center though, then the angle is equal to arc plus arc divided by 2. So that's the situation that we're in. Okay, so we've got the angle, which is right here. Okay, so really when we do this, we wind up making this hourglass shape. Let me try that again. Okay, so we make this hourglass shape wrapped around the angle that we're looking at. So that 84 degrees is the angle. Alright, it's right here on the inside. I'm going to put it on the inside of this hourglass. Well, I guess it looks more like a bow tie since it's sideways. Like a crooked bow tie. Okay? So the two arcs are the arcs on either side of this bow tie or hourglass. So I have the angle and I have one of the arcs. So I could use this to find the other arc. So remember, the formula says angle is equal to arc plus arc divided by 2 for this situation. The angle is 84, so the 84 goes here. A common mistake is just to always put X here. Or some students don't even write down the whole formula. They just try to do the right-hand side, and they think that'll be the answer. But in this case, the angle is 84, so you have to put 84 equals. And then we have arc plus arc divided by 2. So that's going to be X plus 52 divided by 2. To solve this, you want to multiply both sides by the denominator of 2. That way these denominators will cancel each other out. Okay, so that's 168. So now we have 168 is equal to X plus 52. So of course you subtract 52 from both sides. So you wind up with 116. Alright, and that is arc BC. So arc BC is 116 degrees. And then now we're also supposed to find the measure of angle B. Now the measure of angle B doesn't really have anything to do with this formula. So I'm just going to erase all this for a minute. Alright, focusing on angle B, which is right here. Hopefully you can see that angle B is one of those inscribed angles. We're back to this situation right here, where the angle is half the arc. Okay, so you can see that the arc is this 52 degrees. So angle B will be half of that, which is 26. So angle B is 26 degrees. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.